Millions of people hit the play button at the exact same moment and Netflix collapsed. Not from an attack, not from a bug, from success. When Stranger Things Season 5 dropped worldwide, Netflix briefly went down. Smart TVs failed first, applications refused to load, errors everywhere. And then, within minutes, it was back. Even after preparing for a massive traffic, Netflix still hit a wall. And this exposes architecture mistake most engineers still make. Today, I'll be breaking down what actually failed during the Stranger Things Season 5 launch, how Netflix recovered fast, and what this outage teaches us about AWS-scale architecture, real incident response, and why most systems don't fail during load testing, and why most fail when they have real users coming at the same time. If you build systems that are supposed to scale, this lesson matters more than any diagram you have seen. From the user side, it looks simple. You open Netflix, you hit play, and you get something went wrong. Smart TVs were affected first, then mobile applications, then web clients on some regions. No updates were needed, no actions were requested from the users. But on the back end, dashboards were lighting up, alerts were firing, on call engineers were being paged globally. From the user side, it looked like a broken app. From the back end, alerts were screaming. This wasn't a normal spike. A normal spike peaks gradually. This was a vertical wall. Millions of users did not browse, they didn't scroll, they didn't hesitate. They all clicked play at the same time. Now, you all may ask, what's the problem in a million people clicking play at the same time? That matters because traffic shape is more important than traffic size. Now, think of the Netflix like an highway. Netflix didn't run out of asphalt, they ran into toll booths. Authentication checks, metadata fetches, playback authorization, cache lookups that hadn't been warmed up yet. First play events create cache misses, not cache hits. And millions of first play events create what we engineers call a request storm. Smart TVs made this worse. They retried aggressively. If they don't get a response fast, they try again and again and again. No extra amount of bandwidth alone can handle that. Now, here's where most people misunderstand what happened. Netflix was prepared, capacity was scaled, systems were pre warmed, but auto scaling reacts in seconds. This spike happened in milliseconds. By the time auto scaling kicked in, the system was already saturated not by traffic volume but by retry amplification. Some regions failed, others didn't. Some device types broke faster than others could. That's a classic distribution systems failure pattern. Then, how did Netflix recover faster? Not by adding more servers, but by controlling traffic. Rate limiting, request shaping, graceful degradation. Some users were slowed slightly so others could pass. Some non critical parts were deprioritized. Feature plans and backend configs were adjusted in real time. No app update, no user intervention. This is a pure backend incident response. This is textbook large scale incident management. First, we detect the anomaly. Second, we stabilize the system but don't diagnose everything. Third, we restore partial services rather than waiting for perfection. Netflix did not chase root cause immediately, they reduced blast radius. Restore services first, investigate later. This is how mature engineering teams operate. This wasn't luck, this wasn't magic. This is how disciplined incident response happens. Here's the myth that needs to break. Netflix did not fail because it couldn't scale. It failed because success came faster before scaling can react. Load tests don't simulate hype, they simulate averages. Real users behave differently. They synchronize, they retry, they overload control planes, not just data planes. Most outages aren't hardware failures, they are traffic behavior failures. If you are an engineer watching this, here's how to move forward. Design for traffic volumes, not traffic size. Control retires before adding compute. Treat fast access as your worst case scenario. Invest in observability rather than pretty dashboards. Certifications won't save you in incidents. Incident drills will. Success is a failure mode. Plan for it. What's the key takeaway from this incident? Assume success spikes, control retry storms, cache like first access matters, build recovery paths, not perfect uptime. Because if your systems can't survive success, it's not production ready. Smash that subscribe button if you would like to see more real world incident breakdowns and if you don't want to repeat them in production.